Hello 108 class, Mr. McHugh back with you here on section 10.5. On page 3 we're going to tackle a chemistry problem here, and this is common logs and applications on our objectives here. So what we have here is in chemistry, I always try to, if I have any chemistry students and they're going to take chemistry, I always try to work them over and tell the chemistry teacher that their math teachers are helping them here a little bit. But so in chemistry, real quick, you have something called pH, which measures the acidity or alkalinity of a solution. And I think of batteries, we hear of alkaline batteries. We know acid, you do not want to get acid on you, it'll burn. Alkaline, boy, chemistry teachers are rolling here probably. Opposite of acidity. Acid, yeah, you can see me, I do real well talking. So here's the thing, mathematicians come in and try to help out here, and basically they come up with this, in my opinion, a crazy scale that a pH scale starts with 1 if that's very acid, 7 is neutral, and if you have 14 it's alkaline. I have no idea how they came up with that. Okay, sorry. Now what they tell you here is the pH in chemistry is written as negative log, and that's our log base 10, by the way. You can put that 10 in there if you wanted to, of an element called hydronium ion, H3O. And this is my big contribution to the chemistry world. I explained to my math students that what H3O stands for is 3 parts hydrogen and 1 part oxygen. And everybody should know that H2O is water, 2 parts hydrogen, 1 part oxygen. Okay, so there you go, hydronium ion. Now, make life simple for yourself. The math equation for this, I still stick with the pH just because most people are comfortable knowing what it is, equals the negative log of what variable? We'll just pick x. Okay, so there's your setup. Now, if you go to example 2 on page 605, pretend you're helping out a fellow CWI student, happens to be in chemistry, and they're reading about the wetlands, and they are classified wetlands. I think of Miami and the Everglades as wetlands down south. They are classified as bogs, fens, and marshes and swamps, and it's on the basis of their pH values. Okay, a pH value between 6 and 7.5, such as I'm reading this problem to you, as in Michigan's National Forest indicates the wetland is a rich fen. If it's between 3.0 and 6.0, it is, oops, I lost my place. The wetland is a poor fen. I have no idea what fen is, but I'd rather be a rich fen if I could. And if pH falls between 3.0 or less, it's called a bog. So there's a little scale here. Okay, now, so there you go. You got this scale given to you, and now the problem is somebody's taking a reading, and you're told that suppose the hydronium ion concentration from a sample water from a wetlands is 6.3 times 10 to the negative third. What would this wetland be classified? Okay, so your friend taking chemistry, just begging you to help them simply convert and calculate the pH factor, because once you tell them what the pH factor is, they know the table that I just read to you, and they will tell you what classified. They'll do the chemistry part and tell you whether it's a bog or a fen or a marsh or swamp. Okay, so you're like, well, how can I help here? And you can notice here on the example, I kind of, sorry, I was reading from the book here, but here's the classifications for this problem. You got your MSI hat on. This is giving information to you. And you're told let the hydronium ion equal 6.3 times 10 to the negative third. What is the pH and what classification? Okay, mathematicians come in there. You can leave the pH. That's fine. I would leave it there. You say negative log of x. What's x? Hydronium ion. You're substituting 6.3 times 10 to the negative third into the problem, and there's where you're looking at it. Okay, now I'm going to pause here for a moment, because after teaching this over a couple years and I see the advances of technology, I see students will take this problem and they'll type in exactly 6.3 times 10 to the negative third, because they've got scientific notation built into their calculators. We didn't have this years ago, and they hit the buttons and they get the answer. Okay, and the more I thought about it, I'm like, what's to stop somebody? Now let me work my way up here, if you don't mind. I'm working backwards. What's somebody from writing negative log of, convert 6.3 times 10 to the negative third and convert it to decimal? Okay, and back at section, I think it was 5.1, maybe 5.2, didn't we do scientific notation? Now a lot of you guys could probably do this in your head, but if I put 6.3 times, who remembers working the clutch, times 10 to the negative third, I want to get it times 10 to the 0, and so I got to go from let's remember, negative 3 to 0 would be what? Small to big. So I got to go big to small. So I'm going to write my 6.3. I got to go to a small answer, so I'm going to add a couple zeros and move it how many places? 3. And I'm going what? To the left. 1, 2, 3. So 0.0063. What's to stop you from saying the problem is negative log of 0.0063? And look, and I'll tell you what, the answer is nothing. You go in there, you punch it in, you get your answer, you're done. Okay, I understand that. I'm still going to go through and show you how the book does it, just from the old school method here, and they doing this so you could work on over these rules we've been working with. Okay, and so let's go ahead and go the long way. Pretend you forget how to convert scientific notation. You're allowed to take product rule, allows you to replace the log with the two factors instead of multiplication going on, break them apart with addition. Okay, now don't forget that negative's on the outside. And now we're going to go and remember that log base 10, result 10, raised to the exponent, you bring the negative 3 in the front. That's the power rule of log 10, and that's saying what? 10 to the 10 is 10 raised to the what equals 10, and the answer is 1. What exponent? Negative 3. And then log of 6.3, you do this on your calculator. Okay, see if you can, you would use your calculator on there. So you're going to use your calculator, and I kind of go, well, why don't you just be efficient? But I think eventually some of these rules we're learning, I mean, we'll probably teach them, but using them will get less and less because calculators are doing all the work. But anyway, you get 0.7993 minus 3. Answer is negative 2.2 with a minus sign, turns it into a positive 2.2. And here's where you help your friend. You go, well, pH is 2.2. He goes, great, thanks a lot, bingo. He takes all the credit. He or she takes all the credit, calls it a bog, and wins that extra point on his chemistry test, or her chemistry test. Okay, so there you go. That's example 2. Page 3, I think we're going to work another one, go in the reverse direction, so I'll see you then on page 4. Okay, till then, take care. Bye.